Hi folks, let's continue with this exercise 7.2. We are now into the problem number 18, which says that I is e raised to tan inverse x over 1 plus x squared dx. It's for us to decide what is going to be our u. It's very clear to us that e raised to function is exponential function is a complicated function which has got e raised to not simple x but tan inverse x. So we have to make a good substitution there which will help you to make the function less complicated. It's very clear that tan inverse x substitution should be good so that we can eliminate the 1 plus x squared. So let's call u as tan inverse x. So what happens? Your derivative du over dx is 1 over 1 plus x squared, as we all know. Since we require this over here, let's take the dx on the other side. So it's going to be dx over 1 plus x squared, which helps us to quickly translate this I now becomes e raised to u and du. That's it. So e raised to u du we all know is just e raised to u plus c. So when we revert back, it is e raised to tan inverse x plus c. Simple as that, because we did a correct substitution. Now once that is over, let's quickly jump to the 19th problem and see what it says. The 19th problem says that, oh, that's a little challenging problem. Not challenging, you could say tricky or whatever. E raised to 2x minus 1. We see it in the board papers number of times. E raised to 2x plus 1. Sometimes when we are given these kind of quotients, numerator, denominator, sometimes the derivative of denominator is numerator. So that time you can just make a substitution of the denominator and you're able to sort out the issue. But here that's not the case. The numerator is not at all the derivative of the denominator. So that's not going to work. Let us see what else can work. Okay, for our convenience, let's write e raised to 2x as e raised to x times e raised to x. We know that when the bases are same, you can add the exponents. So x plus x can give you 2x. So it's quite okay if we write it like this. So also 1 can be written as e raised to x times e raised to minus x. Why? Because same thing. The bases are the same, so exponents you can add. So x minus x 0. So that way. Same way here. It is e raised to x times e raised to x plus e raised to x times e raised to minus x. Now we did all this so that we should be able to simplify this. So let's see what can be dragged out as common. In the numerator, you can have e raised to x common. So this e raised to x is common. Leftover term here is e raised to x, and here it is minus e raised to minus x. In the denominator also e raised to x is common. So you're left with e raised to x here and you're left with e raised to minus x here. The advantage of this is these e raised to x's are cancelling, and now the numerator is the derivative of the denominator. E raised to x, derivative is e raised to x, e raised to minus x, the derivative is minus e raised to minus x. We have to get that kind of a logic. So it's done. Now what we are going to do is we are going to make a substitution of u as e raised to x plus e raised to minus x. What's going to be our next step? Taking the derivative. E raised to x is e raised to x itself, but derivative of e raised to minus x is minus e raised to x, because e raised to ax has got the derivative a e raised to ax. So it's going to be minus e raised to minus x. Now that you require in the numerator. So your du is going to be e raised to x minus e raised to minus x dx. So finally your I is going to be, this whole thing is du and the denominator is u. So it's just log modulus u plus c, and log modulus u for us is where? It is e raised to x plus e raised to minus x plus c. As simple as that. So that's the 19th problem. 20th one also is on this flavor itself. So let's take what it is. It is e raised to 2x minus e raised to minus 2x. So let me see, let me write it properly before I miss out on the pluses and minuses and all that. And finally, after writing also, I will do a checking, because majority of the times I will miss out on the minuses and then it becomes a huge mess. E raised to 2x minus e raised to minus 2x. Yes, again e raised to 2x plus e raised to minus 2x. Yes, this is not like this. here there was this plus minus, all that was a mess. We couldn't get the numerator as a derivative of the denominator, but here, yes, you are somewhat, not fully, but somewhat, the numerator looks like the derivative of the denominator. Let's make the substitution and see. If we get stuck up, we will do something else, but otherwise we will proceed. So let u be e raised to 2x plus e raised to minus 2x. So what is du over dx? It's going to be 2 e raised to 2x minus 2 e raised to minus 2x. Yeah, e raised to ax has got the derivative a e raised to ax. Okay, but we only require e raised to 2x. Okay, so we'll do one thing. There is a 2 common. Let's take it out. E raised to 2x minus e raised to minus 2x. This is du over dx, but you require this actually. So let's take the 2 on the other side. It's e raised to 2x minus e raised to minus 2x dx. Like that, your I becomes, so that much is going to be du over 2. So this is 1 over u du and 2 outside. Why? Because the numerator is du over 2. So 2 du, that we have written, and this we have assumed as u. That's it. So that's fine. The integral of this is going to be log modulus u plus c. That's it. It solves the issue. So you have log modulus u for us, e raised to 2x plus e raised to minus 2x plus c. That's all. So I think that should be all for this video. With more problems, we might as well meet in the next video. Thank you.